Hello, muli bwanji nonse. Tikufuna ndikulandireneso sabata ino pamene tikufuna kupitiriza phunziro lathu la masamu paja tikupanga circle geometry part 2 ya form 3. So tikhale limodzi pamene tikupanga phunziro lathu la sabata ino. Muli ndine Sisalo Chuma. Sabata yatha tinawunikirana za cyclic quadrilaterals. Tinaonetsana kuti cyclic quadrilateral ndi chani. Tunanena kuti it's a quadrilateral in which all the four corners or four vertices lie on the circumference. Okay? Yeah, tinaonetsa choncho ndituli that's a cyclic quadrilateral. All the four corners lies on the circumference. So we mean these corners, those corners, those corners. Yeah, it's a quadrilateral. An object that has four vertices or angles, but those ones are on the circumference. So that's what we discussed last time, and it now it's kuti opposite angles of cyclic quadrilateral. The first theorem had up to 180 degrees. Okay, angle A and the angle angle A and maybe angle C should be equal to 180 degrees. That's opposite angles should be equal to 180 degrees. And it now needs kuti kodi in this case kuti X and Y, they used X and Y. You see X, Y, we had derived in the two theorem imene pakala now needs kuti X plus Y, it's indeed 180 degrees. So that's the first theorem. We made known it's an quadratic, cyclic quadrilateral, and actually we made known it's an and the exterior, interior, exterior angle is equal to interior opposite angle, which means this angle should be equal to that one. Okay, these angles are equal. So interior opposite angles is equal to the exterior angle. Yeah, so we also showed how to derive that. We had shown that. Please go back and look at that video before you proceed. And we had this example. Yeah, so today kwambiri dikhala kumalizitsa for this topic. So we'll look at another section immediately under circle geometry. We have form 3. This is concyclic points and cyclic quadrilaterals. Concyclic points and cyclic quadrilaterals. Yeah, so when we talk of concyclic points, kwambiri medukamba ndi are just points of any figure, of anything. Command of those points should lie along the circumference. Okay, utokhala ndi chinthu chooneka choncho. Okay, utokhala ndi chinthu chooneka choncho. As long as these points are lying there, these points are called concyclic points. Okay, yeah. You can have any form of a figure, as long as its points are lying along the circumference, those points are called concyclic points. In other words, a quadrilateral has got 4 concyclic points. 1, 2, 3, 4. Okay, so you can have a figure which has got more than 4 points, more than 5 points. So those points are called concyclic points. Yeah, so let's proceed on that one. We have defined that one. Here we have also defined what the concyclic points are points which lie on the circumference of a circle. So yeah, so basically that's that. We can have a thing like this one. We might be asked to show that this item here is a those points, point A, P, Q, R, B, those points are concyclic. Okay, in other words, we have to show that they are lying on a circumference. So ntchito yaikulu ndimene tipange in this part. Komano tikamapanga zimenezo you'll find out kuti almost all the theorems zimene tapanga mu circle geometry will be used here. So I want to urge you to open up your mind, have an open mind. Don't think inside a box. Open it, yeah, so that you should consider all the theorems that you know about circle geometry at this level. Yeah, so basically that's what we are going to do now. Okay, yeah, so we are going to use the very same formulas. We're going to use the very same formulas. Yeah, let's take this out. Yeah, so here we have this example. They're saying we have this figure, and in this figure we have if ABCD is a quadrilateral, ABCD is a quadrilateral in which angle ABC, that's that angle, it's 95 degrees, and the angle BAC, this one is 53 degrees, and the angle ADB, this angle is 32 degrees. The question is to prove that ABCD should be a cyclic quadrilateral. In other words, we need to show that point B, point C, point D, and point A, all those points are lying on a circumference. Okay, so basically that's that. By getting this information, we know that in this case we want to show that this is a cyclic quadrilateral. Okay, so you have to understand what cyclic quadrilateral and its points to lie on a circumference. First of all, we know that there was a theorem where we said opposite angles add up, opposite angles of a cyclic quadrilateral add up to 90 degrees. Number one. We also know that exterior, interior, opposite angle equal. Yeah. So we use a lot of stuff. So we are going to show that here to see which one is working. All right. Yeah. In this scenario, we are given this quadrilateral, and we need to think now. How can we do it? Okay, if you look at this figure, consider triangle B, or I should say ABC. Triangle ABC. You find out that it has that angle, it has that angle, and that angle. Okay, so let's find angle BCA. Okay, angle BCA, you find out that it's 180 degrees minus, in bracket, 95 degrees plus 53 degrees. Okay, reason, angle sum of a triangle, it's equal to 180 degrees. So we'll subtract that and find what is the value of that angle. Yeah, so if we use a calculator to find that, 180 minus, in bracket, 95 plus 53 degrees, you find out the answer will give you 32 degrees. Now reaching this far, you will see that this 32 degrees that we have found up, 32 degrees, how many parts are up? In other words, if you look at them, all these angles are coming from the same line AB. Okay? If you remember as well, my properties are my circle. Circle geometry. Tinali now, mapanga geometry, there was an arc there. Okay? Alright? Tumanena kuti angles subtended by the same arc are equal. So if you look at them, we have AB, them, AC, also akujogera bomofanana kupita. So in circle geometry we know that angles in same segment, you can say angles in same segment or angles subtended by the same arc are always equal. Okay, so if that is the scenario, therefore this thing is a cyclic quadrilateral because it is showing that property. Okay, it is showing that property to say that angle and that angle are equal. Alright, we can say but angle BCA is equal to angle ADB. Okay, that is it. And they are subtended, but they are subtended by same arc. So if they are subtended by the same arc, it means that okay. And if they are subtended by the same arc, it means that sorry, just a moment. Yeah, okay, fine. Yeah, if they are subtended by the same arc, yeah. So we can happily conclude that thing is a quadrilateral. It is a quadrilateral, cyclic quadrilateral. Yeah. So we say but ACB, ACB or BCA is equal to ADB, okay, and is equal to 32 degrees as we have shown there, and those ones are subtended by the same line AB, which is AB, that one, okay, and because that is the scenario, we can make a conclusion that indeed this is a cyclic quadrilateral. Detonate. So now let's look at some examples. Some exercise. I think we do 2 exercises. We do number 3. Okay, they are saying in this figure below, O is the center and of the circle ABP. MO is perpendicular. MO is perpendicular. In other words, it's 90 degrees to AB, which is the circumference. And which is the diameter. And BPM. So BPM, that one is a straight line. Okay, so the question is to prove that AOPM are concyclic points. Okay, in other words, we have to show that that point, and that point are lying on a circumference. So we need to show that. That's our duty now. Okay, so we have this question that's saying in that figure, as we have already explained. Yeah, so choyamba tumanena kuti you have to consider all the theorems So muyeneka muyang'ane muyipanga assess kuti ma points amene wawo kuti akhale concyclic, kuti akhale concyclic points. Which theorem do I have to use? Okay, you can see manager khalira chinthuchi pali ada. Okay, you see that one can be a code, that one. Okay, because this is in your imagination all pambali. Okay, talk on this second of that type. Okay, that this one will be your code. Yeah, so in that case we need to maybe show that angle and that angle. Patokhala njira zina zopangira shows mene. Koma I think pantawi ineyo let me use to show that angle and that angle are equal. Kuti angle theorem ya angle in the same segment ikhale yodani yogwira, or angle subtended by the same arc ikhale yogwira. So if angles are subtended by the same arc are equal, it means that one is a cyclic diagram. If not, all the points are touching the circumference. But here you have to understand that they have given you this one as the diameter, but from that center kwapita line kutupita ku M, and akuza nkuti that one is 90 degrees. Okay, yeah, that one is 90 degrees. So let's start it by doing this. Okay, we can say that angle A L O let's just say let angle A L O to be equal to x. Okay, I'll do that. Let's say that angle is equal to x. So there we are given 90. That one we are saying it's x. So we can say that angle BAP, this angle should be equal to 180 degrees minus 90 plus x, or plus ALO, that angle, right? And this one will be equal to 90 minus x. Okay, so that's the angle there. All right, so now let's consider angle PML. Okay, but maybe before there, all right, before there, you can agree with me that angle PLM, okay, is equal to x, or is equal to angle ALO is equal to x. Reason is the same, vertical opposite angles. Okay, we can say vertical opposite angles. You see, here we are using vertical opposite angles. Something is yeah, so you need to open your mind and understand this message. Yeah, so in this case we can as well say therefore okay, that's x, which means this one is also x, right? Yeah, and the other thing that you should understand is that this one being the diameter, it means any angle in a semicircle, that one is 90 degrees, which means that one is 90 degrees. So therefore you say that angle BPA is equal to 90 degrees. Reason angle in a semicircle. Okay, yeah, so you know that angle is 90 degrees, which means it's obvious that one is as well 90 degrees. Yeah, so reaching this far, we need to find this angle now. Okay, we need to find that angle now. Now let's move from here to there. Then you will say that PML, that angle PML, angle PML is equal to 180 degrees minus in bracket ndekuti 90 uyu plus x uyu. Right, so if that's the scenario, you will say that this one is equal to 90 minus 90, that's 90. I mean 180 minus 90, that's 90 minus x. Okay, so it means we have also found that angle as 90 minus x. Remember here we have also found that angle as 90 minus x. In other words, that angle and that angle ndizofanana. So you will see that they are being subtended by the same arc, or they are coming from the same arc, or they are in the same segment, if you consider that theorem of psychogeometry. So yeah, therefore we can say but angle PML is equal to angle that's BAP as shown. That's the reason, as shown. Then we can say therefore, we can say therefore those points are concyclic. We can say but that one and is equal to that one, which are subtended by same line or P. Okay, yeah, that's the reason for that, and we can conclude that therefore A O P M are concyclic. Yes, concyclic points. So that's part A. And let's try look at part B. For part B, I think let's do it somewhere. Yeah, so we now have part B that's saying angle OPA is equal to angle OMB. We need to prove that OPA, OPA, okay, to be equal to OMB. Okay, yeah, we need to do that. So for us to, let's solve it here. Let's change the color to red. Okay, yeah. So OP okay, so angle OPA is this angle. Okay, it's that angle. So akuna tuonetse kuti this angle is equal to angle OMB, which means that angle. So how do we show that? It's simple. Okay, we have this is a this is a center, which means from there to there it's a radius, from there to there it's another radius. So we have a triangle here, which means this one and that one, they are equal, which means this angle and that angle, they are equal, base angles of an isosceles triangle. So since that one is already equal to that one, we have already shown that, it means that one is also equal to that one, isosceles, base angles of an isosceles triangle. Yeah, so let's show that. Let's show that. Okay, yeah, so basically that's that. Yeah, so the idea is to show that angle OPA is equal to angle that one. Okay, we can say that angle OPA, that's B, angle OPA is equal to angle OPA is equal to angle OAP. Okay, it's equal to angle AP. Angle AP. And remember, angle OAP. Did I base that one bit? Okay. Oh, it may be up a B A P. Okay. Yeah, OPA is equal to B angle B P. No. Angle B A P. B A P. Yeah, B A P. OPA is equal to BAP. This is OPA. Yeah. Reason tubalena kuti base angles of isosceles triangle. Base angles of an isosceles triangle. Yeah. So that's that. Then, but you can say that angle BAP is equal to angle BAP is equal to angle OMP. Okay, is equal to angle OMP. Reason, we have already shown that. Therefore, yeah, proven. So basically that's that. So for this one, that's that. Let's go to another example and see the smakara branch. So let's look at another question that's saying in this figure below, A, B, C, D is a cyclic quadrilateral. So this is a cyclic quadrilateral, and indeed it's a cyclic quadrilateral. All its corners are touching the circumference. And O is the center of the circle. Yeah, so this one is the center, okay, of that circle. AB is parallel, which means that line and that line are parallel. Okay, those are the things that you need to know. And BC produced meets AD at M. Okay, so produced BC, it has been produced. AD produced, they meet at M. Okay, all right. So what is the question? The question here is that we should prove that MCD is isosceles triangle. Should prove that is an isosceles triangle. MCB an isosceles triangle. So triangle when you go an isosceles triangle, it means that line and that line is ofanana. Ndekuti angle iyi ndi angle iyi nzofanana. So it's either we show kuti line and line izofanana for that triangle to qualify being isosceles, or we have to show that that angle and that angle are equal for them to qualify kuti that one is an isosceles triangle. So in this scenario, we are going to show that that angle, so we are going to show that this angle and that angle are equal. So if those angles are equal, it means those are base angles of an isosceles triangle, because they can only be equal if that line and that line are equal. Yeah, so let's see how we can go about it. Alright, in your mind, remember, you are given that as parallel. Yeah, so let's consider angle DCM, angle DCM, which is this one to be equal to that one to be equal to angle ABC. Reason, remember, F angles or corresponding angles. Okay, that line and that line are parallel, which means this one and that one are equal. Those are corresponding angles. Okay, so you can as well know that you have also to know that angle MDC, this angle, to be equal to MDC, this one, to be equal to angle CBA, where CBA. Reason? Simple. Which means this angle is equal to that angle. Okay? Who can tell the reason? It's simple. This is a cyclic quadrilateral. So remember, cyclic quadrilateral, this is like an exterior angle of that cyclic quadrilateral. Yeah, so you can say internal opposite angles amakalofana. So you can say that external angle, internal and internal opposite angles of a cyclic quad are equal. Okay, external, internal, opposite angle are equal, but that one and that one are also equal. Okay, so we can say but angle MDC is equal to angle DCM. DCM and MDC, those angles, and those angles are base angles of an isosceles. Yeah, this is already shown. We have shown that one. Yeah, therefore, you can say that since those angles are equal, it shows that that is an isosceles triangle, since base angles of an isosceles triangle are always equal. Okay, yeah, so that's that. Now the other point is for us to show that ODMB is a cyclic quadrilateral. So we are now going to do B. ODMB is a cyclic quadrilateral. So we have to show that this one, let's do it this way. Yeah, we have to show that this point, that point, and that point are touching, have got the properties that are touching the circumference of a certain circle. Okay, yeah, so let's do that. If you look at this one, we will see that if you try to extend this line, okay, sorry, if you extend this line, you will find out that you have this angle. Let's say this is E. Okay, you can say that is E. So if you extend that one, you will find out that that's B now. We are going to do it on the other page. Let's just go to the other page. Okay, so you will find out that DME, this angle should be equal to interior. Not only that, it should be equal to interior opposite angle, that one. If that is true, we'll understand that this is a cyclic quadrilateral, because that's a property of a cyclic quadrilateral. Yeah, commerce, you should understand for you to find this angle, you find out that you have a triangle here. So basic properties of a triangle, you say that exterior angle is equal to sum of two opposite angles, sum of that angle and that angle. Yeah, so that's, you just have to open your mind and think all the required tools that you have more psychogeometry to make sure that you solve your problem. Yeah, so now let's consider DME. Okay, to say, we are saying DME, let's change the color. DME, angle DME, that one should be equal to this angle and that angle, because of the same reason, that is external angle property of a basic triangle. Okay, yeah, so you say that that one is equal to angle CDM plus angle MCD. Yeah, CDM and MCD, that angle and that angle are equal to that angle. Okay. Yeah, so we let them to be like that. So if we say, if you remember, we can say that, but this angle and that angle are equal. All right, this angle and that angle are equal. So if this angle and that angle are equal, what does that tell you? We already shown that on the first part of the question, to say this angle and that angle are equal. All right, DCM and the MDC here, we shown that here, so they are equal. So we can as well say that, but angle CDM is equal to angle MCD. Yeah, shown. Okay, so for us to solve properly, let's say each angle should be X. Okay, if that is the case, we have already shown that. They are just to make our solving easier. Yeah, so it means that we can say, therefore, angle DME is equal to X plus X, which is equal to 2X. Okay, which means in this case that one is 2X, that one is X, that one is X. Right? So if you remember as well that this angle has to be equal to that angle. Okay, exterior interior opposite angle, because we are told ABCD is a cyclic quadrilateral, so the exterior angle should be equal to that one. All right, yeah, so we can as well say that, but angle DCM is equal to angle DCM. is equal to angle DAB. Reason, exterior angle of a cyclic quadrant. Okay, exterior angle of a cyclic quadrant is equal to internal opposite angle, so we can just put it in short like that. Alright, therefore DAB, this angle should be equal to x, this one. Okay, so we can say that this angle is as well as equal to x. Okay, because we are saying DAB not DAB, CDM, this M or CDM, it's equal to x. I simplify that. So we can say that DCM, angle DCM, remember DCM, this angle is it's a x. DCM is equal to x. Therefore, it's also equal to DAB as x. Okay, so that we can, which means it's also equal to angle DAB. So that's an x as well. So if you look at this one now, it is touching there, it is touching there, it has that arc. So we say angle at the center. Remember, this angle is twice the angle at the circumference, if you remember that theorem. Okay, so in this case we can as well say angle angle DOB, this one should be equal to twice angle DAB, should be equal to twice angle DAB, angle DAB. Okay, which is the same as, because DAB is the same as x, you can say equal to x. Alright, reason, angle at the center twice at circumference. Okay, so if you look at that, since we have found that that is 2x, then if you look at this side here, right, which is an exterior angle of this quadrilateral BODM. Okay, so this exterior angle is equal to interior opposite angles. Okay, we found out that here it's 2x, there it's also 2x. So indeed, since these angles are equal, they are fulfilling the properties of a theorem of a cyclic quadrilateral. The exterior angle is equal to internal opposite angle. Okay, so in this case we can say that part the angle DOB, that angle DOB is also equal to it's also equal to this angle DME. There's an E here, DME. Okay, it's equal to angle DME. Okay, then we can have a conclusion from there to say that we can have a conclusion here to say that indeed, therefore, we can say therefore, and this is 2x as well. Remember that? Yeah. Therefore, what was the question? O D M B is a cyclic quadrilateral. ODMB, yeah, it's indeed a cyclic quadrilateral, because we have shown that this exterior angle is equal to internal opposite angle. Reaching that far, I think we have covered a lot. Tisile pamwepo. Kale ndi sabata yopambana. Ziko.